So today we're going to talk about rules for operations with integers, and you're going to take notes. We have them in your binders to reflect and be able to look back and tell what the rules are. So the first rule we're going to look at is adding integers. And adding integers seems to be an easy one, so I'm pretty happy about that. So I like adding integers. They're simple. So the rules are, if the signs are the same, positive plus positive, you end up with a positive number. For example, 5 positive plus 3 positive would give me 8 positive. Negative plus negative is always going to give me negative. So negative 12 plus a negative 4, all grouped together, is going to give me negative 16. There are no zero pairs, so everything ends up being the same sign. Now, when we talk about adding integers and the signs are different, what we have to think about is which numbers have the negative and positive signs next to them. So for example, a positive plus a negative, or a negative plus a positive, and you might want to write that up at the top of your paper. It could be the other way, negative plus positive, is going to be where the sign of the larger absolute value and we're going to use subtraction. Basically, we're going to find the difference of the two numbers, which is really pretty simple. So step 1 would be finding the difference . And step 2 is going to be taking the sign of the larger absolute value. So now you have that written down a couple different ways on your paper. And there's my absolute value symbols. So take a look at negative 53 plus 46, a negative plus a positive. The difference between 53 and 46 is 7. And if you look on the number line, you could see the difference between 7 hops. And then taking the sign of the larger absolute value. The larger absolute value is the 53, and the 53 is negative. The next number, negative 4 plus 6. The difference between 4 and 6 is 2, and the absolute value of the larger number is the 6. It's positive. Look at 15 plus negative 7. The difference between 15 and 7 is 8. And the sign of the larger absolute value is the 15, and so 8 will stay positive. It's the pieces that are left over. 12 plus a negative 84. This is a larger one, but the difference is going to be 72. And the larger absolute value, the chips that would be left over, would be negative. So there's adding integers, and they seem pretty easy. But we're going to look at subtracting, and I think subtracting is a little harder. So since I think subtracting is a little harder, I put my frowny face at the top. But remember, I said I liked adding, so I'm going to change subtracting to an addition problem. So we are going to add the opposite. So you can change any subtraction problem to an addition problem. That'll make everything a lot easier to work with, but you have to follow the steps. First, you keep the first integer. You never change it. It stays whatever it is, positive or negative. The next thing you do is switch the subtraction sign to an addition sign. And this is the operation. So you have to be careful. Like our 3 is in its parentheses, the subtraction is different from a negative. And the last thing we need to do is use the opposite of the second integer. So we're changing and flipping that second integer to its opposite on the number line. So we'll take a look at 12 minus negative 3. Negative 3 is in parentheses so we can keep it organized. Sometimes you'll see it in parentheses, sometimes you won't. We're going to rewrite it to equal an addition problem. So you're going to write 12, keep the first integer, switch the subtraction to an addition, so 12 plus, and we are going to change that negative 3 to a positive 3, its opposite. So it's easier to say 12 plus 3 instead of 12 minus a negative 3. And then you have 12 plus 3 is 15. Now look at the second example. We have a negative 6. So there's a negative in the front, and we're going to keep it because we're keeping everything with the first integer. Switching that subtraction to an addition, and the 8 is positive, now becomes its opposite, has to be a negative 8. And you can write that in parentheses to keep it organized. Negative 6 plus a negative 8 is out, now easier to look at because they're all negatives, and that would be a negative 14. Another thing to think about, and you guys can write this off to the side, is that when you were little and you learned 5 minus 2 equals 3, what you were really learning way back in elementary school was you were learning that 5 plus a negative 2 equals 3. Now we're going to move on, and we're going to talk about multiplying and dividing integers. Multiplying and dividing integers is probably the easiest, I think, you'll get, because there's a pattern, and all you have to do is follow the pattern. So, same signs, that means if they're both positive, the answer is positive. If they're both negative, the answer is positive. Okay? If the signs are the same. If they're different and there's one negative and one positive, whether you're multiplying or dividing, the answer is going to be negative. So we're going to try a few, but we also have a little cheat or a little friend to help us out. This is your clue, okay? Mark your clue down on your paper because you're going to need to put this clue somewhere else when you're doing your sessions. So this is Mad Bob because he multiplies and divides, and Bob because he's so adorable. And we are going to use the circles to cover up, and you can also use your hand to cover up the pieces in a problem. So for example, let's look at 3 times 4. That's a positive plus a positive. Well, Bob has his 2 eyes are negatives and his mouth is positive. But positive plus positive is so easy, we don't need Mad Bob to do it. So 3 times 4 is 12. And a positive plus a positive is a 12. But now take a look at 3 times negative 4. So when multiplying and dividing, you're doing two things. You're finding out the answer to the multiplication or the division problem, but you're also having to write down the sign to the problem. So because this is a positive and a negative, I need to cover up a positive and a negative. So I'm covering up the sign of the first number, 3, and the second number, negative 4. And what I'm left with in Mad Bob is a negative. And that tells me that my answer to 3 times negative 4 is going to be negative 12. If you take a look at the next problem, the signs just switched to negative 3 times 4. So we're going to cover up the negative first, then the positive, and still get a negative answer, negative 12. The signs are different. Mad Bob can help us do the last problem, where we have a negative times a negative. And if you look at your notes up top, it says the signs are the same, it's positive. We covered up both of Mad Bob's eyeballs and we only have a positive left. So a negative times a negative, because they're the same, is a positive 12. Take a second and look at 15 divided by 3. If you know what 15 divided by 3 is, write it down, and write it down on every line. So 15 divided by 3 is 5. I'm writing it down on every line, and now the only thing I have to do is figure out my signs. So 15 and 3 in the first problem are both positive, so I know that my answer's going to have a positive sign. So I don't need to add anything to my answer. But the next one, 15 divided by negative 3, two different signs, and I can cover up my positive and my negative for Mad Bob, and I'm left with a negative. So it would be negative 5. The next problem says negative 15 divided by 3 is 5, but there's a negative and a positive, not the same signs, different signs, mean the answer is negative 5. The last problem has two negatives, the signs are the same, we cover up Mad Bob's eyes, and only the positives left, so positive 5 is the answer to negative 15 divided by negative 3. Okay, when you're done with these notes, you need to hole punch them and put them in your binder so you have addition, subtraction, multiplication, and division rules all ready for you to review if you need them for homework.